Welcome to the video lecture by Dr. Biju Vasdevan for the course Math for Management 1. The course code is Math113 for JU students. And this lecture is for week number 9. And this is an explanatory video of the PowerPoints available on the blackboard for week 9. So here we solve some problems from the topics 6.1 matrices, chapter 6.2 matrix addition and scalar multiplication, 6.3 matrix multiplication. And we go here. We start with this introduction to this chapter, and this chapter has around 6 topics, and the first 3 will be for this week, and solving system by Gauss Jordan method for week 10, and the rest of the topics, the application, will be for week number 11. Now let's start. Introduction to matrices. Matrices are of fundamental importance in three-dimensional mathematics, where they are primarily used to describe the relationship between two coordinate spaces. They do this by defining a computation to transform vectors from one coordinate space to another coordinate system. Matrices are used in image processing, decision making, cryptography, and economics, etc. At the end of this chapter, we will discuss the application of matrices in economics. Now let's start with introduction to matrices. The definition of matrices: an array of elements arranged in rows and columns. You are arranging elements in rows and columns like this. Let's denote the matrix as A. If I write 4, 3, 2, 1, 4, -5. So this is arrangement of elements in rows. This is called a row and this is called a column. So in this matrix there are 2 rows and 3 columns. So the size of the matrix should be called as 2 by 3. We call it 2 by 3. So 2 is the number of rows and 3 is the number of columns. We call it m by n. M, the letter denotes the number of rows. Small n is the letter denotes the number of columns in general matrix. Let's see some other. Okay, that's what given in the next point. A matrix consisting of m horizontal rows and vertical columns. Vertical columns is called an m by n matrix of order of size m by n. Okay, size m by n, that's what we have seen now. Next, general structure of a matrix. There are m rows and n columns. You can see 1, 2 up to m. A1, 1, A2, 1, A3, 1, A4, 1, finally M1. There are m rows, and the first two, A11, A12, 13, 14 up to 1n, it will be n columns. So the size of this matrix is m by n. The example we have seen a few seconds back. And now for every entry aij, we call ith row the row subscript and the jth column subscript. For example, if we have a matrix A 3, 1, 0, 2, 5, -1, 4, 3, 8. Assume that this is the matrix you have. Now every element is called, this is A11, A12, A13. Aij stands for the element in the ith row and in the jth column. So from the given matrix A, you can say the small aij is element, capital A is the notation of the matrix. Okay, fine. What is in this problem, in this given example, what is A1, A13? Can you try? Yes, 1. First row, third element, third column. First row, third column. You are ending here. That's element. Answer is 0. So what is A3, 2 for this matrix? Third row, second column, third row, second column. Answer is 2. Ith row, jth column, 3, 2, A3, 2. Isn't it? So what is A2, 3? A2, 3. Second row, third element. The answer is 1. Here it is 1. That is it. So let's go to the next slide. Now we are going to see some types of matrices. What is column matrix? We will write a matrix with only one column. We can say this is an element of a example of a column matrix. 1, 2, 3, 4. See, what is the size of this matrix? Can you try? What is the size of this matrix? If I give this is your matrix A, and there are 4 rows but only one column. 4 by 1 is the size of this matrix. So this is called only one column vector. We call it column matrix. And next, row matrix. Now you have an idea what is this is A. Another we can call it B. 4, 3, 4, -1, 0 and 6. How many elements? What is the size of this matrix? There's one row with 5 elements, isn't it? So one row, 5 columns. One row, 5 columns. The size is 1 by 5. What's next? Square matrix. Okay, that's an important point. The same number of rows and columns. So obviously, if I write A is 2, 1, 1, 3. This is square matrix. The size is 2 by 2. When the number of rows and number of columns are equal, we call it a square matrix. You can write square matrix for any size. See, in this case, we call the sizes order. Order is 2 here because when m and n are equal, we call it the sizes order of the matrix. Then order of the matrix is 2 here for this square matrix of order 2. Now we can try order 3 where the size is 3 by 3. Next is a zero matrix. If all the elements in the matrix are zeros, try your own example. 0, 0, 0, 0, 0, 0. So size 2 by 3 matrix where all the entries are 0. So we call it zero matrix. Upper triangular matrix. The elements, okay, upper triangular matrix. Upper triangular matrix. What is upper triangular matrix? Can you guess? Any guess? For some time. See, the elements are located below the let me clear off all the write up. Okay, fine. Now the elements are located below the leading diagonal are zeros. What is it? So upper triangle, you have a matrix now A. Can write 1, 4, 3, 6, 0, 2, 4, -1, 5, 0, 0, 5, 7, and we can write 0, 0, 0, 1. The size of this matrix is 4 by 4. There are 4 rows and 4 columns, isn't it? See, you see this is called leading diagonal. The diagonal starting from A11, A22, A33, A44, all these elements. This diagonal is called leading diagonal. If all the entries below the diagonal are zeros, we call it upper triangle. See, this is the entries, that is the non-zero entries are in the upper triangle of the matrix. This is it. So upper triangle. In the similar way, you can try a lower triangular matrix. Lower triangular matrix. So the next definition I can try. All the entries above the leading diagonal will be zeros. So try the example yourself. Right. Let's see diagonal matrix. Diagonal matrix is another called, we denote it by using D. We can write 1, 0, 0, 0, 2, 0, 0, 0, 3. In example of diagonal matrix, all the elements non-zero entries are in the diagonal. So non-zero entries are only on the diagonal, other entries are zero. So this is called a leading diagonal. All the leading diagonal entries are non-zero, other elements are zeros. So when you get This kind of matrix we call it a diagonal matrix. Next, scalar matrix. If all the entries in the diagonal are same, scalar matrix called S. You can try 3 0 0 0 3 0 0 0 3. This is a diagonal matrix. A special case of diagonal matrix where all diagonal entries are equal to other, isn't it? So they are equal. A11 is 3, A22 is 3, A33 S11 is 3, S22 is 3, S33 is 3. So that is called a diagonal matrix. Scalar matrix. Next, identity matrix. Third, identity matrix I. We denote it by using I. For any order. See here. Diagonal. So we can call this an diagonal matrix, identity matrix, where diagonal elements are 1. Other elements are zeros. The leading diagonal elements are 1 and all other elements are 0. We call it I. So I3, if it is a square matrix of order 3 by 3, size 3 by 3, then we call it I3. In the similar way, we can write I2, identity matrix of order 2, 1 0 0 1. So we can write identity matrix for any order as a square matrix. If you write identity matrix square matrix with the same number of rows and columns, where all the leading diagonal elements are just 1, then we call it I1, I2, I3 as identity, the notation for identity matrix. Next, symmetric matrix. Symmetric matrix is a different concept. We need to know what is transpose of the matrix. So when I explain you transpose of the matrix, I will give example. Symmetric matrix. When you are given a matrix A, you find its a transpose, and when the resultant matrix is equal to the original matrix, then we call the matrix symmetric matrix. Generally, if you find leading element, it will be symmetric. When you find, in this cases, Aij will be equal to Aji, except that the leading element, all entry will be symmetric about this diagonal. If it is 3 here, it is 3 here. If it is -1 here, -1 here, 5 here, 5 here. This kind of matrix. When you exchange the rows and the columns, you will find a transpose of the matrix. We will see it in coming slides. See some examples. Sizes of the matrix. This is the size of this matrix is 1 by 3, and the size of this matrix is 3 by 2. There are 3 rows and 2 columns. This is singleton matrix, so size is 1 by 1. In this matrix, the size is 3 by 5. That's it. Okay. Now, equality of matrices. Matrices A, the matrices A and B are equal. First condition, if they are of same size, and each and every element wise they are equal. That is, first element A11 in A is equal to B11 in B. So we can say that A is 3 2 5 7 and B should be the same size. This is 2 by 2, then B should be of same size. So if we write 3 2 5 7, then A and B are equal matrices. The size is same 2 by 2, and element wise A11 is A11 is equal to B11, which is 3, A12. So element wise things will be equal. That's it. Transpose of the matrix. Just now we have seen symmetric matrix. Now we will understand what is symmetric matrix. So transpose. A matrix, a transpose of an m by n matrix, A denoted by A transpose, is the n by m matrix whose ith row is the ith column of A. That is, you take the first row of the matrix and make it as column. So one as well in first row 1 2 3 of A, has been written as 1 2 3 is a column of A transpose. So second row becomes second column. So exchanging rows and columns here, isn't it? So the if the size of the original matrix is 2 by 3, the size of the resultant matrix is 3 by 2. That is this. So when we find again at another transpose, this will be back to A. That is A transpose of transpose is A. So transpose of matrix, just write rows into columns, the new matrix. You will get the resultant matrix is called a transpose of the matrix. That's it. Okay, let's see one example, one beautiful example for this case. See, I give you matrix A. 1 2 3 2 -1 4 3 4 0. Now find a transpose, A transpose. Change the rows. So change the rows into column. First row is 1 2 3 1 2 3. Second row is 2 -1 4. 2 -1 4 is the column of this matrix. Third row is 3 4 0. 3 4 0 is the column of the matrix. Did you find they are same? Yeah, of course. So when a matrix and its transpose are equal, we call it symmetric matrix. That's it. We have seen the definition already. The next, we are entering to exercise problems or exercise. It's again example problems. Okay. Problems 6.1. We are actually, this is exercise problem. Okay. Problem 6.1. Question number 1. There are 4 and 8 matrices. Find the size of every matrix. This is a trivial case. I think you can try yourself. Just try the size of 1 or 2 matrices and then I leave, isn't it? Matrix A is of size 2 by 3. B is a square matrix size 3 by 3. And the matrix of matrix E 4 by 4. You can find the sizes of other matrices. How many matrices are square? B, D, E, H, all these are square matrices. Which matrix? Size of each matrix. So size of each matrix should be done here. Here write the square matrices. And then which matrices are upper triangular here? Upper triangular matrices. So above, below the diagonal, leading diagonal, all entries are 0, isn't it? For upper triangular. And first find upper triangular matrices. What do you get? Yes. See, answers are here. You can find H and a lower triangular D. This is for upper triangular and this is for lower triangular. We have seen examples already. So now which of the row vector? This is row vector and this is column vector G. That's it. Very trivial case this one. So we go for the next problem. What is the order of A? Order is the size of the square matrix, isn't it? This is 4 by 4. So order is 4. Order of the matrix A is 4. The next, find A21 from this matrix. A21, second row, first column. Second row, first column is 6. So the first answer is 6. Find A24, second row, fourth element, -2 is the answer. Construct the matrix. This is the important case of this topic. Construct the matrix B. So size is 2 by 2, isn't it? So we are going to construct a matrix B whose size is 2 by 2. There are 2 rows and 2 columns. We call this number first number element B11, second the row first row, second column element 1 2, second row, first column, B21, B22. So we need to find all these one here. I represents the number of rows and J represents number of columns, isn't it? The formula for Bij has been given here. So if I want to write B11 here, the case is I is 1, J is 1, isn't it? J is 1. So Ij B11. How to write the formula? Minus 1 to the power I minus J. 1 minus 1 into 1 square minus 1 square. So what do you get? 0. When I and J are 0, I square when I and J are equal, you get 0. This is 0, 1 minus 1. Okay, so B11 is 0. What is B12? Second element. This has been found. This we are finding now. B12. What is the case? I is 1, J is 2. So negative 1, 1 minus 2. Minus 2 and 1 square minus 2 square. What do you get here? Negative 1 to the power negative 1, which is negative 1, and here 1 minus 4, which is negative 3, negative 1 and negative 3. The answer is 3. So the second element is 3. Third, we will find B21. B21. Negative 1 to the power I minus B21. I is 2, J is 1. J is 1. So you get negative 1 to the sorry, I is 2. Yes, I is 2, J is 1. So 2 minus 1 here, and 2 square minus 1 square. What is it? 2 minus 1? Negative 1 power 1 is negative 1. This is 4 minus 1 is 3. So the answer is negative 3. Finally, B22. When I and J are equal, it will be 0 by this formula. By using this formula, we will find I and J are equal. Then it will be I square and J square will be minus I square minus J square will be 0. So B22 should be 0. So what is the matrix B? Finally, B11 is 0. B12 is 3. And this is negative 3 is 0. This is the matrix finally. The next example we'll see. Construct the matrix. Again another. So this is important. There are some problems in the assignment of this same model, and there may be questions. If there is a final exam, questions of this model can be asked. So you have to concentrate on this type of questions first. Here we are constructing another matrix whose size is 2 by 3. 2 by 3. So write down the matrix D. D11, D12, D13. 2 row and 3 columns. Isn't it? The size is 2 by 3. So 2 second row. D21, D22, D23. Now find all the 6 elements and you are done. All the 6 elements. What is so this is I to the power negative 1 to the power I and J cube. The formula, isn't it? So what is D11? D11 negative 1 to the power I is here. I is 1, J is 1, isn't it? Negative 1 to the power 1 and 1 cube. 1 cube is 1, is negative 1. The first answer is negative 1. What is D12? I will find first row. I will leave the second row for your calculation, for your practice, isn't it? D12. Here I is 1, j is 2, so negative 1 to the power 1, 2 cube, which is negative 8, d13, negative 1 to the power 1, 3 cube is 27, so it is negative 27. And you will get all these numbers when I is 2. When I is 2, the second column, for the second row, all the elements involved I is equal to 2. Therefore, it will be positive negative 1 to the power 2, d21 negative 1 to the power 2, and j is 1 cube. You get positive 1, and d22 will be 8, d23 will be 27. Therefore, the required matrix will be negative 1, negative 8, negative 27, 1, 8, 27 is the second row. That is it. The size is 2 by 3. That's the answer to this problem. The next, you are given a matrix A is Ij. The size is 12 by 10. How many entries does A have? You know, the size is 12 by 10. It says that there are 12 rows, isn't it? In each row there are 10 elements. So we know that there are 12 rows and 12 rows and 10 columns. So the total number of elements will be 12 into 10, 120. Because in every row there are 10 elements. Okay, now if Aij is 1, what they give? Aij is equal to 1 and 0. Second, Aij 0. For I is equal to j, for I not equal to j. So when this is not a square matrix, actually there are 12 rows, 10 columns. We don't need to write the entire matrix right now, isn't it? We just need to identify when it will be 1 and when it is 0. That's it. When I is equal to j, the entry will be 1. I equal to j appears only in the leading diagonal. All other entries are zeros. So leading diagonal A11, A22, A33, A44, all these entries are 1. When the row and column are equal, when I and j, when the numbers in the subscript are equal, then you get 1. If they are different, you get 0. So now find the answers for this one. A33 answer is 1. A52 answer is 0. A10 by 10, A10 the answer is 1. A12 the answer is 0. That's it. Write the 0 matrix of order 3 and of size 2 by 4. Write 0 matrix. Answers are on the PowerPoint, you can check. Find a transpose. We have already discussed how to find transpose, so I quit this problem. Symmetric or not? Check this is symmetric. Find transpose. This is given matrix A. Call it A. Find transpose. Change the rows into columns. First row 2, negative 1, 0. First row becomes the first column in the resulting matrix. Second row minus 1, 5, 1. Third row 0, 1, 3. Now check both the matrices. They are equal. So this is symmetric. So A transpose of all transpose. Find the transpose twice and check the result is same or not. This practice problem to you. And now this is given that two matrices are equal. This is A matrix, this is B matrix. So element the size are same. So the first matrix is of size 2 by 2. Second matrix also is of size. So the next condition is element wise it should be equal. So 3x should be equal to 9. You will get the value of x as 3. Second entry 2y minus 1 should be equal to the second entry, that is this A11, this is B11, this is A2 1 2, this is B12. Second element A12 should be equal to B12, that is 2y minus 1 should be equal to 6. Solve it, you will get y. So it is y is equal to 7 over 2. Third, z is equal to 7 straight away. Z is equal to 7. 4. 5w is equal to 15 gives w is 5. That is it. Now let's go to the next topic, matrix addition and scalar multiplication. So when we can add two matrices, what is the condition for that? And obviously, what is the operation, how we operate it, and then how to multiply a scalar with a matrix. This is what we are going to discuss in this chapter. Matrix addition. If A and B are both m by n matrices, I mean both the matrices of same type, and sum of A plus B is the matrix m by n, resultant matrix is also of the same size m by n, obtained by adding corresponding entries of A and B. Element wise we are going to add a very simple example. I will show you here. A matrix 1 4 10 3 6 12. This is matrix A. I give you another matrix with the same size. If you get a different size matrix, we can add it, isn't it? So negative 1 3 negative 12 4 7 negative 10. So there are this both the matrices of same type, same size. This is 2 by 3 and then A is also 2 by 3. What do you mean by A plus B? Element wise, first element goes with the first element. 1 plus negative 1 0. 4 plus 3 7. 10 plus negative 12 negative 2. 3 plus 4 7. This 3 and this 4. 6 plus 7 13. 12 plus negative 10 2. This is the resulting matrix, and the size of this matrix is also same, 2 by 3. That is it. And in the case, this is an example of addition of two matrices. A, you can try this example. And here B we cannot add because the size are different. Sizes of these two matrices are different. We cannot add this one. So that is it. Some properties of addition, matrix additions being given here is commutative, associative, and identity matrix. The trivial properties. Now, how to multiply a scalar with a matrix. So this a matrix is A is of size m by n and k is any real number. Then how to multiply the k with the A is done by multiplying the scalar with each entry of A, and the order remains same. So let's see an example. These are some basic properties of multiplication. You can go through it. We are not verifying these properties right now. And what is scalar multiplication? Let us take a matrix A. 13 12 11 10, let it be matrix 9 8. This is of size 3 by 2. Now I take a k is negative 2. So I want negative 2 times A. Multiply negative 2 with A. Every element of A will be multiplied by negative 2. That's it. Negative 2 into 13, negative 26. Negative 2 into 12, negative 24. Negative 2 into 11, and negative 22, negative 20, negative 18, negative 16. That is it. So all the entries have been multiplied by negative 2, and we got a new matrix. That is it. Okay, this is the way multiply. So now property of subtraction. Subtraction is a kind of addition with a negative sign. So just the same task will be multiply by negative one and then add using addition rule. That's it. Subtraction of matrices, and the rule is the same. Perform the indicated operations when they are defined, where they are defined, right? Two matrices have been given of same size. The size is 2 by 2. The size is 2 by 2. You have to add a term by term. 7 plus 3, it is 10. Negative 3 plus 4, you get positive 1. Negative 2 plus 5, and you get 3. 1 and 2, you'll get 3. That's it. So this cannot be added because the sizes are different. This is of matrix. This is the matrix of size 2 by 2. This is the matrix of 2 by 1. You cannot add it. Now here we go. That's a different question. Now this kind of problems are expected. So we are given three matrices of same size. This is of size 2 by 2. This is of size 2 by 2. This is all the matrices are of same type. So we can add, subtract, or do anything. These matrices. What is it? 3 times 2a. So 2 times a matrix. What is a matrix? 2 1 2 1 3 negative 3 minus 3 times b. B is negative 6 negative 5 2 minus 3. Close the bracket. This is the bracket actually, right? It is equal to 3. Multiply this 2 inside. 4 2 4 2. This is 3. So 6 minus 6 minus 3. Multiply 3 inside. Minus 18 minus 15 6 minus 9. Now subtract these two matrices and multiply 3. You have to do it here. We are going to okay, the next step I can show you here. There's no space. Okay, let me write here. Subtract the matrices. 4 plus 18 is 22. 2 plus 15, so negative and negative will be positive. 15 17. 6 minus 6 will be 0 minus 6 plus 9 will be 3. This matrix will be multiplied by 3, and the resultant matrix is 66 51 0 9. That's the end of this problem. You try this one. B minus C and then transpose. Find B minus C first. 1 minus 1 is 0. 3 minus 0 is 3. 4 minus 1 3. Minus 1 minus 2 is minus 3. Now B minus C transpose is just transpose. First row becomes first column. Second row becomes second column. That's it. The answer. And both the matrices are same, isn't it? So this is symmetry matrix. Now we are given addition of two matrices. So this is the first matrix is 3 by 1 size. This is 3 by 1. Again the resulting matrix are also 3 by 1. So we add these two to equal to this one. So the first two matrices. 2 plus 2 into x. 2 plus 2 into x. 2x is equal to negative 10. So when they are equal, element wise matrices, element wise they are equal, isn't it? 4 plus 2y is equal to negative 24. 6 plus 2 into 4 that is 8 is equal to 14. Solve them. What do you get here when you solve x? Solution, we know how to solve equations, we have already seen it. So when you solve x, you get x is negative 6. You try this one. 2 will be negative 12, so that is it. Y will be negative 14 and z will be 14 minus 6, it will be 8, divided by 8 will be 1. That is it. The next topic is 6.3 matrix multiplication. How to multiply two matrices? What is the condition for that? That's what we are going to discuss in this topic. See, we are given two matrices. A matrix A is of size m by n, another matrix B of size n by p. And you notice here the matrix A has m rows and n columns, whereas the matrix B has n rows and p columns. Then the product AB will have m rows and p columns. The missing element is n, isn't it? So this n is the crucial factor. When the number of columns in the first matrix is equal to the number of rows in the second matrix, we can multiply two matrices, otherwise we cannot. That is the, so if the number of columns of matrix A is not equal to the number of rows of B, then the product AB is not defined. That's what the major condition, and then we will see how. So these are some properties. We have to add one important property. In the case of matrices, the product AB is not equal to BA. There are many failure cases, not always equal, right? So this is another important property. It's not commutative but associative property, distributive property, scalar multiplication, all satisfied. So this is transport. The transport of the product is equal to product of the transport. The property we will check some problems. Okay. Now identity matrix, we have already seen what is identity matrix. So let's go to the product, check whether the matrices can be multiplied. Now we have these two matrices A and B. A is a matrix of size 3 by 5 and B is a matrix of size 5 by 3. See, this 5 should match with this 5. Then we can say the resultant matrix AB is this element 3 by 3 matrix. It is possible to multiply A and B because number of columns in A is equal to number of rows in B. The last entry in this subscript is equal to the first entry in the subscript of B. Therefore, the size of the resulting matrix will be this first entry and the last entry, 3 by 3. So now, will you try BA? Is it possible to multiply BA? B, size of B is 5 by 3, size of A is 3 by 5. But it is possible, isn't it? So the entries match. Number of columns equal to number of rows. So we can multiply BA and the output matrix will be of size 5 by 5. See, here you have seen AB is a square matrix of order 3, BA is a square matrix of order 5. They are not equal, they are different. And we have given two different matrices CD, whether CD or DC, possible you try yourself. Now some more problems have been given. For example, a row matrix multiplied with the column matrix, isn't it? So here the size of the first row matrix is 1 by 3. The column matrix is 3 by 1. So we can multiply this number of columns equal to number of rows. First I'm matching the last number. So the answer will have only one element because the resultant matrix will be of order 1 by 1. So now how to multiply? first element goes with the first element. Second, this is actually sum of the products. Multiply and then add them. First element goes with the first element, second element goes second element, third element goes with third element. Multiply it. First element is 1 into 4, 4 plus 2 into 5, 10 plus 3 into 16, 18. So the total is 18, 28, 32. 32 is the 1 by 1 matrix. Now try this one. This is a row into column. Now this is column into row. We are multiplying a column matrix with a row matrix, isn't it? The size of the column matrix is 3 by 1. The size of the row matrix is 1 by 2. Are they matching? Can we multiply? Yes, the number of columns in the first matrix is 1, number of rows in the second matrix is 1, they match. So we can multiply. How to multiply now? The resultant matrix should be of order 3 by 2 because this 3 and 2 will play a role in the size of the resulting matrix. Now how to multiply? Just take this 1, multiply with every element in this go. So 1 into 1, 1 into 6. Next 2, take 2 and multiply with every one. 2, 12. Take this 3, multiply with every one. 3, 18. That is it. So 3 rows and 2 column matrix, we got it. So this is how to multiply a row with a column or column with a row. This will be done for matrices of higher orders. Now we are going to compute the product of these two matrices. Here D. We are given two square matrices of order 3 each. This is of size 3 by 3 and this is of size 3 by 3. Number of columns, the first matrix equal to number of rows in the second matrix. So we multiply these two to get a new row, new matrix whose dimension is again 3 by 3. Say 3 by 3. So what to do first? Take this row and multiply with this column. Element wise, 1 goes with 1, 3 goes with -2 and 0 goes with 2. So what happens here? This will give you the first element in this matrix. 1 into 1, 1, 3 into -2 minus 6, 0 into 2, 0. So the answer is I'm writing the answers here. The answer is 1 minus 6 plus 0 is minus 5. Now the second row should go with the second row should go with the second column. Second row should go with the second column, and element, first element with the first element, second element with the second element, third element with the third element. Multiply them and then add. Okay, no, let's just wait for one more time. I'll come from the beginning. Actually, we should have finished the first row with all the 3 columns to complete the first row here, isn't it? That's right. I'll be repeating it again. One more time. We're writing here the answer. And so this is of size 3 by 3. This is of 3 by 3, and the result will be resultant matrix is also 3 by 3. We can multiply since the size meet. Okay. Now what should we do? Take the first row, multiply with the first column and second column, third column to write 3 elements. So first element, 1 into 1 is 1, 3 into -2, -6, 0 into 2 is 0. So the answer, this total is -5, that we write here. Second, this row with the second column, 1 into 0, 0, 3 into -1 is -3, 0 into 1 it's 0. So the answer is -3 for the second, and Again for the third column, the same row with this third column. First element with the first element. 1 into 2 is 2. 3 into 3 plus 9. 0 into minus 2 is 0. So it's 11. It's 11. So in the same way we will try by taking the second row. We will use with every column the second matrix. So second row with the first column, negative 2 with this one, negative 2 with 1, negative 2 and 2 with minus 2, minus 4, 1 into 2 plus 2. The answer is negative 4. Here we write. And the same row with the second row. First element minus 2 into 0, minus 2 and 0. 0, 2 into minus 1, minus 2, 1 into 1. This is 1. So the answer is here negative 1. The same second row with the third column. First element with the first element. Minus 2 into minus 2, minus 4, 2 into 3 plus 6, 1 into minus 2, minus 2. So you get 0. Now take the third row, do the same with every column. First element with the first element. First row, the third column with the first row. First element with the first element. 1 into 1, 1. 0 into 2 plus 0. Minus 4 into 2 minus 8. Minus 8 plus 1 minus 7 is the first element. The third row with the second column. First element with the first element. 1. 0 into minus 1, 0. 4 into minus 1, 4 and minus 4 into 1 is minus 4. So this is check it one more time. 1 with 0, 0. 0 with minus 1 is 0. Minus 4 plus 1 is it minus 3. Should have been minus 3, isn't it? 1, 2, 1, 0 into, actually this is 1 and this is 0. 1 and 0 is 0. 0 into minus 1 is 0, and minus 1 into minus 4 into 1 is minus 4. So the third row column elements with the second column elements becomes this one. So what you get is minus 4. Finally, third row, the first matrix with the last column, third column of the matrix will give you the last element. Here, we will try here. 1 into 2, which is 2. 0 into 3, which is 0. Minus 4 into minus 2 plus 8. 8 is 10. That's it. How to multiply two matrices. Take one row from the first matrix, multiply with every column, and then write the first row of the resulting matrix. Multiplication is element wise, and then add them together. That's it. Now here find the size and number of entries. Okay, there are A, B, C, D, E and F. There are 6 matrices. Find the size and the number of entries each of the following. Okay. D, can we find D and E? What is the size of D? Is 4 by 3. What is the size of E? 3 by 2. So this numbers match, therefore we can multiply DE and the resulting matrix of order 4 by 2. So 4 by 2. In the resulting matrix you have 4 rows and 2 columns. So there will be totally 4 into 2, 8 entries. Number of entries. Number of entries is equal to 8, and the size is 4 by 2. Size is 4 by 2. So that is the answer for case 8. What's the next question? E transpose B. First tell me the size of E. Is 3 by 2. What is the size of E transpose? Where is E? Transpose it, you will find 2 by 3. Rows becomes columns. Columns become. So if you find a matrix of size A by M by N, the transpose will have the size N by M. So just interchange the rows into columns. And what is the size of B? Size of B is 3 by 1. It is 3 rows, 1 column. Column, isn't it? Now let's find the first two. It is possible because these two numbers are matching. So E transpose, when you multiply, you get an outcome matrix that is of size 3 by 3. Now we can multiply it by 3 by 1 because these two numbers match. And the outcome matrix E transpose B is of size the first number and the last number. Listen to 3 by 1. So the size, answer for this part is size is 3 by 1. So number of entries is 3. 3 into 1 is 3. What is next? So let's clear the screen. The answer is also given here. Next, in the following problems, perform the indicated operations were defined. So two matrices have been given, each of size 2 by 2. What is the question? Just multiply them. Just multiplication has been discussed. You can try this for this matrix. Answer is on the board. And again, matrix multiplication we have discussed. You try as a practice problem. The answer is on this PowerPoint. Now again, matrix multiplication. All these problems are of matrix multiplication. Compute the required matrix. What is it? AI minus O. So this is AI minus A into 0. 0 matrix into A, 0 matrix again. A into identity matrix. A into any matrix with identity matrix is the same. Any matrix with 0 matrix is 0 matrix. So at the end we will get A matrix. The operation is being given here. That's it. What is A matrix is being given here. Now that is, and we will multiply matrix multiplication. We will do matrix multiplication for one more problems and then close this one. Take this. I will show you only 1 or 2 steps, then we complete this. Take this row, multiply with this column, isn't it? So 4 and 1 into 2, 4 into 0, 1 negative 1 into 1 minus 1. So this is the first element. Second, here this row with this column, 1 into 1, 4 into minus 1 minus 4, negative 1 into 1 negative 1, and 1 into 0, 0, 4 into 1 plus 4, negative 1 into 2. Third column we are dealing with negative 2. This is it. In this way you can fill. Now the first row elements are 8 minus 1, 7, 1 into 2, 4 into 0, actually this one, 4 into 0, 1 minus 1, so this is 2 minus 1, this is 1, 4 into, actually what should have been done here, 1 into 2, 4 into 0. Okay, I'll explain right from the beginning. It is how to perform the matrix operations, isn't it? this first row with this first column element wise 1 into 2 4 into 0 minus 1 into 1. So 1 into 2 4 into 0 minus 1. So the first entry is minus 1. Note down here the result. Next, the same row with the second column 1 into 1 1 into 4 into minus 1 minus 1 into 1 minus 1. So 1 minus 5 minus 4. The second row element, isn't it? The first row second column. Now first row with the third column 1 into 0 0 4 into 1 plus 4 negative 1 into 2 negative 2. So 4 minus 2 2. So we have finished the first row. In the similar way, if you choose second row with the first column, you will get this element. Second row with the second column, you will get this element. Second row with third column, you will get the third element of the row. You can try the rest of these problems. And that's it. I think this topic is for the next week, so we can stop here. You can send me the questions and doubts through Blackboard or mail or WhatsApp as you wish, and we will discuss. Thank you very much.